Hello, students. We'll continue with the organic part, and today we'll be doing the last part of 12th class organic, that is functional group 3. Well, as far functional group 3 is concerned, it basically involves nitrogen containing compounds. That is, here we are going to study about amines. We'll see amines, that is RNH2 compound. We'll study about diazonium salts. These are the two parts which you are going to study in your 12th standard. Otherwise, in functional group 3, we generally have amines, diazonium salts, nitro compounds, cyanide, isocyanides. So we'll stick to these two things, amines. So today we'll be starting with amines, and we'll see, first, before starting with amines, we'll see what's the difference between primary, secondary, and tertiary amine, and what amines they look like. Well, as far amines are concerned, they are ammonia derivatives. So ammonia, we know very well that ammonia is like this, where you have got a lone pair of electron and you have 3 hydrogen atoms attached to nitrogen. So ammonia looks like this. But in this case, if you remove or substitute a hydrogen by an alkyl group, you'll get amine. Before starting with amine, I would just like to show you one thing, that in case you have got a compound like CH3, CH2, NH2, another compound you got CH3, CH, CH3, NH2, and yet another compound you got, say CH3, 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 NH2. Here I would like to tell you one thing, that all these amines are primary amines. This is 1 degree, this again is 1 degree, this again is 1 degree. In amines, we do not look at the hydrocarbon chain, the structure of the hydrocarbon chain. In fact, we have a look at the number of hydrogen atoms which are present at nitrogen. So if you got 2 hydrogen atoms attached to nitrogen, that means you have got a primary amine. Whereas if you have got only one, then it's a secondary amine, and if you know, then it's a tertiary. So in primary amines, you'll have 2 hydrogen attached to nitrogen, and in secondary you'll have 1, and in tertiary you'll have no hydrogen attached to nitrogen. And this is what you can see here also. All these amines, this one, this one, this one, all these amines, they have 2 hydrogen attached to nitrogen. That means all of them, they are primary amines. Dear students, it is necessary to know difference between primary, secondary, and tertiary amine before starting with the chapter, because we'll be dealing a lot of reactions over here where we'll be dealing with primary, secondary, and tertiary amine. Like, we'll be talking about their basic character, we'll be talking about the difference or the test to differentiate between primary, secondary, and tertiary amine. So we'll proceed further, and first we'll see their method of preparation. So we'll see their preparation, how to prepare them. Well, preparation of amines can be done by reduction of nitrogen containing compounds. So we'll see that also. So first is by reduction. By reduction of nitro compounds. By reduction of nitro compounds. So suppose I've got a compound like CH3, CH2, NO2. I'm reacting it with 3H2 in the presence of nickel and heat. It's a good reducing agent, good catalyst, nickel, platinum, palladium. So I'll get a compound like CH3, CH2, NH2 plus 2H2O. So primary amine I'm getting here. I can prepare amines by reduction of cyanides and isocyanides. by reduction of cyanides and isocyanides. So suppose I got a compound like RCN. Again I am adding hydrogen because reduction is addition of hydrogen. In the presence of catalyst nickel and heat, I will get compound RCH2NH2. You will see that it's a primary amine. So reduction of cyanide will give us primary amine. Let's see isocyanide. So I have compound like R and triple bond C plus 2H2 in the presence of nickel and heat will give me RNH CH3. Dear students, you can see that in this case nitrogen has got only one hydrogen. That means the amine which I am getting is 2-degree amine. The limitation of this method for isocyanide is that although you are getting 2-degree amine, but that amine is always an methyl alkyl amine. No matter what alkyl group you have got here, but here you will always get a methyl group because you have got only one carbon on this side of nitrogen. That on reduction will form methyl group. So always you will get a secondary amine, that is N-methyl alkyl amine. So this is reduction of cyanide and isocyanide. You can also get amines by the reduction of oximes. By the reduction of oximes. Well, as far oximes are concerned, we have already done them in aldehyde and ketone also. Whenever you react an aldehyde or a ketone with hydroxylamine, you get an oxime. Here I am showing you an oxime of acetone, that is propanone, and it is like this. Just want to make a correction. You'll have only one hydrogen here, not two hydrogen. Because oxime has got OH group also. So this is an oxime you have got. Now if again you are reducing it, that is you are adding hydrogen into this in the presence of nickel and heat, you will get a compound CH3, CH3, CH, NH2 plus H2O. So in this case you will see that you are getting a primary amine. So this is how you can prepare amines by the reduction of oxime, cyanide, isocyanide and nitro compounds. Next method I'll tell you, that is from acid amides. Will involve three methods in this, and all of them they are very important. First I'll show you. First is by a reduction. By reduction of acetamide. So if I got a compound like RCONH2, this is the acetamide I have got, and I am reducing it to H2 in the presence of nickel and heat will give me RCH2NH2 plus H2O. In this case, you are getting a primary amine. Well, student, many a time a conversion is given to you. Kindly remember these things which I am telling you, that suppose you got a conversion in which you have to convert ethanol amide to ethane amine. Simply do the reduction. I am writing that example here. Suppose you have been given a conversion in which you are asked to convert ethane oil amide, that is CH3CONH2, and you have been asked to prepare ethane amine. Simply do reduction of this. You will get CH3, CH2, NH2 plus H2O. So you are having same number of carbon atom on either side of the reaction. In the reactant side you got 2 carbon, and in the product side again you are having 2 carbon. But many a time in the conversion the carbon atoms are reduced. Suppose you have been asked to convert ethanol amide to methane amine, then what you will do? You have to reduce one carbon atom, that is you have to carry out degradation. So second method we'll see by degradation, that is reducing the carbon chain. Now in this case, suppose again I have got same compound, that is ethanoyl amide. Now in this case I will react it with Br2 in the presence of 4KOH. That will give me CH3NH2 plus 2KBr plus K2CO3 plus 2H2O. So in this case, you will see that carbon atom, one of the carbon atom is reduced. So you are getting a primary amine over here, which has got one lesser carbon. On the reactant side, you have 2 carbon, but on the product side, you got only 1 carbon. So whenever you are required to convert ethanoyl amide to methane amine, carry out this degradation process, in which in this process we heat it also. And this process is known as Hoffman-bromamide reaction. Hoffman-bromamide reaction or Hoffman degradation process. So whenever you are supposed to reduce a carbon atom, kindly carry out degradation. If the carbon atom on both the sides are same and you are required to convert amide to amine, carry out reduction. Next, from acid I am telling you, and this the reaction which I am about to tell you has got 3 questions, 3 exercise questions in your textbook. So the third one is by Gabriel's phthalimide synthesis. It's one of a very good method of synthesizing primary amines, primary aliphatic amines. Before starting with this, I would like to tell you what a phthalic acid is. Phthalic acid is benzo 1,2 dioic acid. We'll see this reaction in detail. So here I have got COH. Here again I have got COH. If I react this compound with ammonia, 2 hydrogen from ammonia and 2 OH group from carboxylate will come out as 2H2O. And I will get a compound like this. I am writing it like this. This compound is not different, it is all the way same. See this, if this is number 1 and this is number 2, then you can write it like this. This is number 1, this is number 2. Not a problem in writing it like this. This compound is phthalimide. An amide is always acidic like an acid. So phthalimide is also acidic like phthalic acid, and it has a tendency of donating this H positive ion. So if I reacted with a base like KOH, OH negative ion from the base will combine with H positive ion and they will come out as H2O. I will get a compound like this, that is CO and K positive and negative. This is potassium phthalimide. Now, whatever amine I want to prepare, I have to take that alkyl halide. Suppose I want to prepare ethane amine. I will take ethyl chloride, CH3, CH2, Cl. K positive and Cl negative, they will come out as KCl. You will get a compound like this, CO, N positive, CH2, CH3. So this is the compound you are getting. This compound is N-ethyl phthalimide. And in the last step, what you have to do? Just hydrolyze it. So what you are doing? H2O in the presence of H positive. Here I'm not balancing it, but to make the reaction easier, what you can think that you have taken 2 moles of H2O, which will give you 2 moles of H positive and 2 moles of OH negative. These 2 moles of OH negative, one will combine here, another will combine here. So you'll get phthalic acid again, that is COOH and COH. And the 2 hydrogens, they'll combine with nitrogen. So when they will combine with nitrogen, the compound which you will get is CH3, CH2, NH2. So you are getting a primary amine. This is the primary amine you are getting. And this is the method of synthesizing 1 degree aliphatic amine. Well, here I would like to add some concepts to this reaction, because these concepts, they have been asked like a question in your textbook. The first thing is, see, first I'll revise whole of the reaction once again, and after that I'll tell you those concepts. See, we have got what? We have got phthalic acid, that is benzo 1,2 dioic acid. I'm reacting it with ammonia. 2 hydrogen from ammonia and 2 OH group from phthalic acid. They are coming out as H2O. You will get phthalimide. So here you are getting phthalimide. This phthalimide is acidic. If you react it with a base, OH negative from the base will combine with H positive. They'll come out as H2O. You'll get potassium phthalimide. This is what you got. Now, whatever amine you want to prepare, take that halide. You can take methyl chloride, ethyl chloride, propyl chloride, or butyl chloride, depending upon the type of amine you want to have. And if you reacted with this, K positive and Cl negative will come out as KCl. You will get N-alkyl phthalimide, so N-ethyl phthalimide. If you hydrolyze this compound, you will end up with phthalic acid and that amine. Here I would like to add one thing, students, and that is very important. First, only 1 degree amines can be prepared by this method as phthalimide contains only 1 hydrogen atom that can be replaced by only 1 alkyl group. So you'll get only primary amines. Second, you cannot get aromatic amine by this. So only aliphatic amines can be prepared by this method as aryl halide cannot be used in place of alkyl halide, since there is a double bond character between halogen and carbon. So it is difficult to break it. So these are the 2 limitations, that you can get only primary amine by this method, no secondary and tertiary, and only aliphatic amine, no aromatic. because if you'll use instead of this, suppose instead of this alkyl halide, you are using aryl halide. Suppose you are using chlorobenzene. Then in that case, there is a double bond character between chlorine and carbon, and it is very difficult to break this bond. So that is not going to react. So only aliphatic amine can be prepared by this method. So this is all about the method of preparation from acetamides. We have seen reduction of acetamide, degradation of acetamides by Gabriel phthalimide synthesis. Next, what we can do is from alkyl halide. So third is from alkyl halides. Now let's see how to prepare them from alkyl halide. Suppose I have got a compound CH3, CH2Cl, and I am reacting it with NH3. In this case, one H and Cl, they will come out as H2O. I'm sorry, they will come out as HCl. So you'll get a compound that is CH3, CH2, NH2. Dear students, here two hydrogens, they are attached to nitrogen, so you have got a primary amine. This primary amine will again react with the alkyl halide because like ammonia, they are also basic. So you'll get a compound that is CH3, CH2, Cl. And you are reacting it with CH3, CH2, NH2. Again, one of the H and Cl, they will come out as HCl. You will get compound that is CH3, CH2, whole twice NH. So here in this case, you are getting a secondary amine. This secondary amine will again react with alkyl halide. So if you got an alkyl halide, the same alkyl halide that is CH3, CH2Cl, and this will react with CH3, CH2, whole twice NH. Again, one of the H and Cl, they will come out as HCl, and you will get CH3, CH2, whole thrice N. 3-degree amine you are getting. But this reaction is not going to stop here because even the 3-degree amine has got a lone pair of electron which they can easily donate to a carbocation. So next step you can have like this CH3, CH2, Cl plus CH3, CH2, whole thrice N. You'll get a compound that is CH3, CH2, whole 4 N positive and Cl negative. So here a quaternary salt you are getting, and this compound is tetraethyl ammonium chloride. So when you react an alkyl halide with ammonia, you'll get the mixture of these amines, and this reaction is known as Hofmann aminolysis. This Hofmann aminolysis. This is what you're getting. So this is all about the method of preparation of alkyl halides. So in today's class, we have done the method of preparation of alkyl halides, and in the next class, we'll be starting with their chemical properties. So this is what we were scheduled to do today. Thanks a lot. Thanks for joining. And I request all of you to please subscribe my channel so as to get all the notifications on time. Thanks for joining.